Okay, so in the last video, we looked at a simple example where we had two metals. One was being oxidized and one is being reduced. But there may be cases, as we're going to look at now, where we have a redox reaction that happens in either an acidic solution or a basic solution. So we use what's called the half reaction method. We could have used this method in the last example as well. So we first write our skeletal equations, and what I just mean write our oxidation half reaction and our reduction half reaction, right? So we first need to assign the oxidation states so we can figure out what's being oxidized and what's being reduced. From there, we're going to balance each half reaction for all elements except hydrogen and oxygen. Next, we're going to balance each half reaction for oxygen by adding water. And we balance for hydrogen by adding a proton. And then we balance for charge on both sides by adding electrons. Next, if needed, we will multiply one or both of the half reactions so that the number of electrons that's consumed is equal to the number that's produced in the other half reaction. So that when we add the two half reactions together, the electrons cancel out and then we can simplify. Now, if the reaction takes place in a basic medium, our next step would be to add hydroxide ions to both sides of the equation to neutralize any proton ions in the solution and then simplify. So let's look at an example so that these steps can make more sense. All right, so we're going to write the balanced equation for the redox reaction between solid copper and nitric acid. And we produce or yield aqueous copper 2 ions and nitrogen monoxide gas. So you can write out just that overall reaction, right? Copper plus nitric acid yields copper 2 plus nitrogen monoxide. Our first step is to write the two half reactions, right? So we know that copper is being oxidized because we go from copper with a overall charge of 0 to 2 plus. So it's losing 2 electrons. And then our reduction is nitric acid. So it's actually our nitrogen that is being reduced, right? So pause this video, right, and determine what the oxidation state of nitrogen is here versus in our product. And you should see that it's being reduced. So nitric acid, the nitrogen in nitric acid has a charge of +5. +5. Whereas in nitrogen monoxide, it has a charge of +2. +2. So it is gaining electrons. So step 2, we're going to balance each half reaction for all elements except hydrogen and oxygen. So everything is balanced here. Everything is balanced here, right? So the elements that are except hydrogen and oxygen, right? We've got our copper, we have one molecule in both, and then our nitrogens are balanced here. So step 3, so I'm going to put the previous step on the top just so we can see how we got to the previous step. So now moving to step 3A. So remember, this is when we balanced everything except hydrogen and oxygen. Now we're going to balance the half reactions for oxygen by adding water. So let's look at oxidation first, right? That's going to stay the same because we don't have any oxygens. But in our reduction step, we do have oxygens, right? We have 3 oxygens in our reactants and 1 on our product side. So to balance it out, we're going to add waters. So since we have 3 here and 1 here, we need to add 2 waters to our product side so that we have 3 oxygens in our product as well. So now our oxygens are balanced here. So keeping that previous step there, now 3B, we're going to balance each half reaction for hydrogen by adding a proton. So similarly, our oxidation step stays the same. Reduction, however, changes, right? Because we have 1 hydrogen on our reactant side and then we have 4 on our product side. So we need to add 3 protons on our reactant side so that we have 4 protons on both sides. So now our final step for balancing our half reactions, we're going to balance the charge by adding electrons. We're going to balance the charge by adding electrons. So starting with our oxidation step, right, we have a charge of 0 on the reactant side and 2 plus on the product side. So if we add 2 electrons here, then that will cancel out our positive 2 charge and we'll have a charge of 0 on both sides. We'll have a charge of 0 on both sides. For our reduction half reaction, we need to add 3 electrons because we have a charge of 3 plus, right? Because of these protons that we added on our reactant side. Our product side is neutral. So when we add these 3 electrons on our reactant side, that cancels out that plus 3 charge here from the protons. So now we have a neutral charge or charge of 0 on both reactant and product side. So now we're going to multiply one or both half reactions so that we have the same number of electrons consumed in our reduction half reaction as the same amount that's produced in our oxidation step. So we have 2 electrons that's produced in our oxidation half reaction and 3 that's consumed in our reduction step. So we need to multiply our oxidation half reaction by 3 and our reduction by 2 so that we can balance the electrons. So that's our reaction when we multiply it by 3. And then our reduction step, we multiply by 2. This is what we're left with. So now we have 6 electrons, right, that are going to cancel each other out. So now we're going to add the 2 half reactions together. So when I add these 2 half reactions together, adding everything on the reactant side, everything on the product side, this is what I get. And simplify, just meaning canceling out anything that appears on both sides. So we can cancel out our 6 electrons. And this is what we are left with. 3 copper solid plus 6 protons plus 2 nitric acid yields 3 copper 2 plus ions plus 2 nitrogen oxide plus 4 waters. So this is our balanced redox reaction. Now, if we were in basic conditions, right, we would need to add hydroxide ions to neutralize these protons. But in this example, we are in acidic condition. So this is our balanced redox reaction. So I actually want you to try this one on your own, which is an example in basic conditions. You're going to write the balanced equation representing a reaction between aqueous permanganate ion and solid chromium 3 hydroxide, which produces solid manganese 4 oxide and aqueous chromate ion. The reaction takes place in a basic solution. So you're going to follow the exact same steps, balance in the exact same way. You will just have an additional step at the end where you will neutralize your protons by adding hydroxide ions. So try this one on your own.